After the moon formed, it was much closer to Earth than it is today. The gravitational interaction between the two caused powerful tides and slowly pushed the moon farther away. Even today, the moon continues to move away from Earth at a rate of about 3.8 centimeters per year. Early in its history, the moon's surface was molten because of the heat from the impact and from radioactive decay inside it. Eventually, the surface cooled and solidified, forming the gray, cratered surface we see today. Scientists support the giant impact hypothesis because of several important pieces of evidence. First, the composition of moon rocks, brought back by the Apollo missions, is very similar to that of Earth's outer layers. This suggests that the moon was formed from material that once belonged to Earth. Second, the moon has a smaller iron core compared to Earth, which fits with the idea that it formed mostly from the lighter material ejected into space. Finally, computer simulations of large impacts show that such a collision could produce a moon-like body with the same orbit and composition. However, the giant impact hypothesis is not the only theory. Before it became widely accepted, scientists proposed other ideas. One was the fission theory, which suggested that the moon was once part of the Earth and was thrown off when the planet was spinning rapidly. Another was the capture theory, which proposed that the moon formed elsewhere in the solar system and was later captured by Earth's gravity. A third idea, the co-formation theory, claimed that the Earth and moon formed together at the same time from the same cloud of dust and gas. But these theories have major problems. For example, the fission theory cannot explain how the Earth could spin fast enough to eject the moon, and the capture theory cannot explain how Earth's gravity could capture such a large object without destroying it. The co-formation theory fails to explain the differences in the iron content between the Earth and moon. Although the giant impact hypothesis fits most of the available evidence, scientists continue to refine it. Some details remain uncertain, for example, how exactly the debris clumped together, and whether Thea's material mixed completely with Earth's. New computer models and laboratory experiments are helping researchers explore these questions. Additionally, future lunar missions, such as those planned by NASA's Artemis program, will collect new samples from the moon's surface. These samples could provide even more clues about its mysterious origin. The formation of the moon was one of the most significant events in Earth's history. The moon has played a vital role in stabilizing Earth's rotation and tilt, which in turn helped create a more stable climate that allowed life to evolve. Without the moon, days would be shorter, tides would be weaker, and our planet's climate might be far more chaotic. In summary, the moon likely formed about 4.5 billion years ago when a Mars-sized body collided with the early Earth, creating a massive disk of debris that eventually came together to form the moon. Although some questions remain, the giant impact hypothesis gives us a fascinating picture of how our closest cosmic neighbor came to be, born from the same violent beginnings that shaped our entire solar system.
The formation of the moon. The moon, Earth's only natural satellite, has fascinated humans for thousands of years. From ancient myths to modern space exploration, people have always wondered where it came from and how it was formed. Scientists have proposed several theories over the years, but today, most evidence supports one major idea, the giant impact hypothesis. This theory suggests that the moon was created from the debris left behind after a massive collision between the early Earth and another planet-sized body. To understand how the moon formed, we need to go back about 4.5 billion years ago to the early days of our solar system. At that time, the solar system was a violent and chaotic place. Planets were still forming, colliding, and gathering material from the surrounding disk of gas and dust left over from the birth of the sun. Earth, which was still young and extremely hot, had not yet developed the stable conditions we know today. According to the giant impact hypothesis, a Mars-sized object, which scientists have named Theia, was orbiting the sun near the early Earth. Over time, their orbits crossed paths, and eventually they collided. The collision was catastrophic. Theia struck Earth with tremendous force, melting much of both bodies and ejecting a huge amount of material into space. This material, mostly consisting of vaporized rock and metal, began to orbit around Earth, forming a ring similar to the rings of Saturn, but much shorter-lived. Over time, this debris began to clump together under the force of gravity. Within a relatively short time, perhaps just a few thousand years, these fragments merged to form a single large body, the Moon.